and welcome to Recurrent Patterns, where we look for interesting patterns in technology, business, and culture. I'm your host, Vaclav Vincalek. Today on Recurrent Patterns, I have extremely very special guest, Dr. Eric Siegel. There are so many things we can say about Eric. He is the founder of the predictive analytics world, several conferences. He is also the Coursera instructor, where he's running a free course about data analytics. Eric, what else can I say that you do?
Well, thanks, Václav, and thanks for having me. So, the sort of biggest part of my consulting career in the last dozen years has been this conference series we started in 2009, which is called Predictive Analytics World, and it's the leading cross-vendor conference series focused on the commercial deployment of machine learning. Predictive analytics is largely a synonym to machine learning. I'm the author of a book called Predictive Analytics, and the subtitle is an informal of the definition of the field. So it's Predictive Analytics, the power to predict who will click, buy, lie, or die. And then most recently, as you just mentioned, I'm instructor of the course series of 3 courses on Coursera that are accessible for free, called Machine Learning for Everyone. And that title should be taken quite literally, because indeed, the curriculum applies both for business side learners who are non-technical and want something accessible that covers both the business value, business process, and core technology of how to make use of machine learning, but then also covers a whole bunch of advanced topics, an accessible introduction to actual algorithms, the methods, and sort of all the pitfalls, the organizational pitfalls, the technical pitfalls. These are pretty interesting, understandable to all types of learners. So it's very much, if you're on the technical side, it really is supplementary to hands-on training. Most of it's not actual hands-on, but it covers the technical topics and the business side process. So Machine Learning for Everyone is the name of that course series. You can find out how to access it for free, like a lot of stuff on Coursera, by going to machinelearning.courses.
And for everybody, don't worry, all the links and all the topics Eric mentioned, it will be part of the video, and it will be attached to the video. So everybody will be able to click on the links and go directly there. And I can definitely say from my own personal experience that the data analytics for everyone is extremely good course. Highly recommend to anybody who's watching this.
Thank you.
Of course. So the topic of this video show is recurrent patterns, and I would like you, if you can start sometime maybe when you started with data, and think about what is same, what patterns do you see in the whole data world, what we can learn, and what maybe can help us to predict where we're going.
I mean, I first became fascinated with machine learning in 1991 during the summer between college and graduate school. I think that machine learning is, as it's often called, the new electricity. Andrew Ng calls it that. The Harvard Business Review calls it most important general purpose technology of the century. This is the most actionable form of data crunching, of analysis, because it's learning from data to predict. To make predictions about each individual customer, corporate client, individual satellite that might run out of battery, product rolling off the assembly line, transaction that might be fraudulent, et cetera, et cetera. On the consumer or healthcare patient side, it's very much about individual humans. But the defining characteristic there is that we're applying machine learning, and that's what we mean by predictive analytics, is the use of machine learning to learn from the data, to render these predictions per individual, in order to inform and render more effective all the large scale operations, all the main activities that organizations and companies do, right? All the stuff that we as large groups of organized people do that make the world go round. So targeting, marketing, fraud detection, credit risk management, right? Assembly lines, manufacturing, supply chain, just like all these things where there's lots of individual decisions that that could be improved, even just slightly, has a tremendous impact on the bottom line. Those improvements are driven by per individual predictions. So it's funny when you think about recurrent patterns, the concept that drives your vlog here, that applies in two very different levels of granularity, right? And I think that we're here today to talk on the higher level, where we're talking about this technology. It used to be called data mining, predictive analytics. It was always called machine learning. I started as a business consultant outside of academia in 2003. And at the time, we called it predictive analytics. Machine learning was a strictly academic term, and now it's also used in the industry world, but it's all, arose by any other name. So if we're going to talk today about what are the patterns of the evolution of the field, of the buzzwords, of the technology, the core techniques, of the way that it's used, the understanding, the hype cycles, all these things, that's at the higher level. And then at the lower level of granularities is, of course, how machine learning actually works, because that's what it's doing, is it's determining patterns in the data.
Yes, very much. And also what resonated with me, so there are a few things which you touched on, is the hype. I think that the disservice which technology people or technical people, data scientists, they always learn to start using or allow others to start using words or terms which are, they obfuscate the actual meaning of what it's supposed to do and create the false expectations that systems can do something which they were not meant to do that, or they are even capable of. And of course, the typical one is artificial intelligence, right? That would be one hyper word which everybody's using these days without really understanding what it is.
Yeah, AI is the greatest perpetrator of, excuse me, I bumped my table. AI is the greatest perpetrator of vaporware, right? Yes. So there's a big problem using the word intelligence when you're talking about STEM, right? Engineering. When you're building something, the word intelligence is nothing if not subjective. It's not just that it's vague, and it's not just that there's different definitions. It's that there is no formal definition that can possibly satisfy. So therefore, it's not a reasonable goal to pursue with engineering. So I take a pretty strong stance, and I taught the artificial intelligence graduate level course at Columbia University a long time ago. And at the time, it was sort of a cluster of methods, right? Which include machine learning, but also includes this idea of search, which is basically how you get a computer to play a board game like chess, and just tries lots of possibilities, but it can't try all of them. So you have some constraints and guidance on how it does that. Great ideas, but by putting the word intelligence on it, you front load the expectations, and it creates a lot of problems. It's overhype. It's easy to be tempted to get on that overhype bandwagon. But if you're talking about machine learning, which typically is supervised machine learning, where it's learning from labeled data, from examples for which you already know the answer, then, just call it that. Don't use an overzealous word that does convey false promises, and is going to definitely lead to another bubble bursting, because AI goes through these AI winters. And my contention is that, well, as long as we keep calling it AI, there will always be AI winners.
Yes, and when you say AI winter, it always reminds me of Neuromancer, the book by William Gibson, which I really like. And definitely many things which you say, the AI should be left to science fiction than to real work, if you will.
Yeah, no, I'm a big fan of AI in the context of science fiction, just on a personal note, right? I love a lot of science fiction movies. I just saw Interstellar again, and its take on the AI robots is a lot of fun. Super unrealistic if you just take so much for granted just by anthropomorphizing a machine, but a heck of a lot of fun when you suspend your disbelief. But the other place it applies very much is in philosophy. And I grew up having in-depth conversations with some family friends about what would it mean for a machine to be intelligent. I was always fascinated by the question, and it is what led me to a career in supervised machine learning, because I think that that's where you can get astonishing things to work. But I don't draw a comparison between how a computer learns and how a human learns, like a baby. I would draw the comparison between how a computer learns and how evolution creates a species, if you were going to draw a comparison.
Mm-hmm. I think that by talking about artificial intelligence, it helps us better to understand ourselves, because from completely side note, when we implementing systems for companies, I always say the technology piece is always the simple part, because when you try to insert technology into process where technology is either 1 or 0, there are no gray areas. And suddenly you realize that people actually don't know how the process is working. And the AI in this context is a prime example of it, because we would like AI to make decisions for us, yet we still don't know what the right decision is supposed to be. Therefore, how can we know that the AI is making those good decisions?
Well, you're touching upon an ethical issue that applies to real technology, right? To non-fictional technology, machine learning, right? So that's a huge area of concern. And there's a lot of work in ethical machine learning concerns. People do call it ethical AI. I mean, people do use the word AI as synonymous to supervised machine learning in a lot of contexts. The real problem is that that's certainly far from consistently the case, right? But in any case, whatever you call it, the ethics of automated decisions based on data with machine learning, with whatever method, comes up because you're driving very consequential decisions about who's going to receive approval for a credit application, for housing, a job, or last but not least, whether they're going to remain in prison, whether they'll get parole, what their sentencing guideline will be given to a judge based on predictive models that are developed from data with machine learning. And the problem is that models are often opaque. So they are complex and hard to understand. And you can show from the data that by certain measures, they do better than humans for certain tasks, right? They can sidestep certain kinds of human biases. They can be more consistent, where judges are shown to have their rulings greatly determined by how hungry they are, this kind of thing. But now that we're systematically institutionalizing formal decision-making in a data-driven way, then you very quickly find out that that when you break down by protected classes like race, certain groups, especially disenfranchised groups, turn out to only be further disenfranchised by way of this process. It's pretty complex. So this is called machine bias. There's also cases where people want to actually incorporate protected class as a direct part of the decision-making, which in a sense is even worse than what's the well-known machine bias, where I refer to it as explicitly discriminatory algorithms, where the model that machine learning has developed has been permitted to take the protected class as input, in which case it would potentially literally penalize the individual for all of these kinds of consequential decisions based on their race.
Yeah, then you basically start self-fulfilling prophecy, right? You just enforcing the stereotype, if you will, and I think that everybody experience this on their own when they go, to store somewhere where you say, well, "Can you do this for me?" And they said, "I would love to, but the computer doesn't allow me to do." Mm-hmm. And that happens, and that nothing drives me mental more than this, where I know how these systems are built. I know exactly where the problem is, and what would be the right term? The sheepiness of people saying, "Well, I would love to do something, but the computer doesn't allow me." But basically, they relinquish the power of humanity, if you will, to basically somebody else make some decision, the anonymous. And I think the anonymous part of this whole thing is the dangerous piece.
So I think part of what you're alluding to is that essentially the decision-making kind of patterns or rules that are embodied by these models are essentially policies, right? And even if it's for decision support rather than decision automation, such as a judge who takes as input a human into his brain, into his or her brain, takes as input, right? Takes into consideration the recommendation or the flag of a computer model to render a decision that could determine how long someone stays in prison. The judge is still making a human decision, but is informed by a probability that's been calculated for that individual suspect or convict. Even though that still allows for the informal process, human process, for that type of decision support scenario, the fact is the recommendation of the computer will still most certainly be the deciding factor for uncountable numbers of cases. So you still have these potentially grave injustices actually committed by computers. So that's why I think it's very important when you think about how to handle these issues and start to set ethical guidelines, ethical standards, is that what you're constraining and trying to target isn't just math or data-driven, optimization, but it's policies. It's the semi-automatic generation of little policy-making machines, right? And so their regulation, the establishment of standards, I believe, needs to be viewed not just as a bunch of platitudes like let's be fair or avoid bias, because these words are pretty subjective, but they need to be concrete. That is to say, we need to be forthright and very active and establish these standards as an act of social activism.
I very much resonates with me. I've been part of developing various systems, and on many occasions, people express the desire that the system should be fair. And I always object the word as either stupid or it just does not make sense. And I always say, even the devil is fair. So just don't use word which can mean something to somebody else without real context. It's wrong. I think that the better word is transparent.
I would say that transparency is one of the main key standards that should be widely accepted, but it's not. Most of these consequential decisions are black box, right? Either literally in terms of the math is sort of a soup and there hasn't been the right effort to decode it. But maybe even, but it can be. That's a fairly solvable problem. But maybe more significantly, it's black box in that it's conducted by a computer that's in a locked room, right? So, for example, law enforcement agencies around the country pay for third-party vendor solutions that make these risk scores for convicts, these probabilities, such as one called Compass, and those are black boxes. They're proprietary, and you're not allowed, the judge, the convict, you can't cross-examine this virtual witness because you're not allowed to look inside the box. It's locked up.
Yes. So this is perhaps too pessimistic, perhaps too dark. We should talk about some, a little more uplifting things about data.
Right. So I was about to say, because we sort of just covered a problem with publicity, which is the term AI is sort of a loaded term and it's probably misleading. And we just talked about some of the general ethical issues. But I was also going to say the same thing, right? So let's sort of focus on the glass half full here for a second. I have Alan Turing over my left shoulder, and he's not just there as a goof, right? Even though it's kind of a cute colorized photo of him there. He's my hero, right? So he's the father of computer science. He's well known for also some work cryptography and decoding of the Enigma machine in World War II, but more generally, the very notion of computation, the idea of what a computationally complete mechanism, and all computers are, came from him, and some of the the basic philosophy on what would make a machine intelligent, which he really established a lot of ideas around that, which may have led us into a rabbit hole. But even before computers had physically been built, he was already speculating and trying to establish how you would answer those kinds of philosophical questions. But at the same time, it's quite inspiring. And the fact is, on the ethics side, it's good news, right? Because now we are driving things with data. So we have the opportunity to more generally apply standards, because we have all of these formal systems that are driving decisions, and they're doing it based on data. So it's all on the table. We can see exactly how to measure the way different groups or communities may be treated by the model. We can evaluate it, we can measure it, we can report on it, and we can implement changes to it, right? So rather than it being in the human brain as purely human processes where it is a black box, and that's very difficult to discern, there are even greater opportunities. And then sort of outside the ethical conversation, of course, what we're really talking about here is an amazing tool, the ability to learn from data, to drive all these mass scale operations and make the world a more effective and efficient place, right? I mean, the way we're treated by companies and organizations is our experience in modern society. And these are improved and, product recommendations and how we're marketed to, and healthcare improvements. There's a lot of good being done around this. Vilifying it is a huge mistake. Doesn't help either side of the conversation. And the fact is, it's like making a knife, right? Nobody's talking about outlawing knives. They can obviously be misused, but I would really hate to carve up a cantaloupe without one, right? I mean, it's very valuable, and this transcends, a physical implement. I mean, this has so many areas of application, and it's being used in good, explicitly for social good, right? To improve fundraising and to improve the way resources are used, to improve who gets micro loans for people who would otherwise not be able to attain loans through normal channels. All sorts of application areas explicitly for social good, and then also just for sort of the general improvement of effectiveness and efficiency, which is by no means a bad thing in general, right? So this is human progress. It's just that it brings up a bunch of new questions that are challenging and need to be addressed, right?
Yeah, and 2 points on what you described. Going back to patterns, or where Alan Turing was thinking about computers or computing on at that time perhaps completely theoretical level. I always give example where part of the machine learning is linear regression. When that math was invented or was established, 1700 something like that. You are the professor, you should know that, right? Or Fourier transformation, which helps us to do the signal processing, right? So that these are concepts which are old, and then they came to fashion when technology caught up with it. And I think that the example of history is very important to emphasize that what we have these days has been work of people 10, 100 years ago, and now it's coming to fruition. So that's one thing, or one point. And the other point is about using the term machine learning, and you very nicely point out that actually machine learning can be also positioned as a human learning, because using machines we can learn so much about things which were hidden for us for such a long time, because we did not have the capacity, the technology available to do the discoveries for us. And the medicine, better treatment, better drugs is prime example, because we can learn now how to do things far better.
Yeah, exactly. So the core technology, the idea of learning from data does go back to linear regression. It goes way back. And a lot of projects even today I mean, linear regression is rarely the last recourse, but something like logistic regression, which only builds on linear regression relatively small amount. It's not that much more complex than a linear model, which is a weighted sum. It just also has some nonlinear thing going on. And that alone is often sufficient. And the thing that really matters is the data. So there are advances in the core technology, but the biggest advances that are making the biggest difference are the availability of more data and the availability of more computation power. But then I'd say the third ingredient is the actual uptake. So the general understanding of what this stuff is capable of and how it's so much more pervasive now across industry sectors, across lines of business, across operational parts of all sorts of enterprises. Now, that isn't to say that the core learning algorithms aren't improving in significant ways. And the biggest improvement that's taken the world by storm is what's called deep learning, which is a form of neural networks. And for certain applications where the thing you want to make a prediction about or classification about is big, like a full resolution image, is there a traffic light in this picture? Is there a stop sign? Is it a cat or a dog, right? That's really, really hard to just sit down and program a computer to make those distinctions. But by giving many positive and negative examples, labeled examples, and letting it churn out, it's deep learning that's capable of producing what are very complex models, but do extremely well in distinguishing between these large objects, whether they're high resolution images, sound for speech recognition, even video. So you could sort of think of as high volume or high large signal processing problems. So in that way, that area that is, I would say it's not a recurrent pattern on the macro scale, because this is new. We haven't seen anything like this that just came up over the last several years, what deep learning is capable of. But it's tackling sort of a new area set of problems. So, image processing, speech recognition, it's kind of distinct from the stuff from the business arenas where machine learning was more traditionally applied, right, for targeting marketing, fraud detection, credit risk management, and those sort of business application areas, right? So now we have this more advanced technology that can deal with really, in the business side, usually what you just have is a few dozen or a few hundred data points about each individual that you're trying to make a prediction about, like this customer, all their purchase history and their demographics. Would they purchase this product if I sent them a brochure, right? Based on those factors, right? Whereas in the sort of more engineering side, medical images, self-driving cars, that whole area where you have a large amount of data, that is, say, all the pixels of a high resolution image, for example, that's where deep learning applies. So it's sort of stemmed out into a complementary area where machine learning is now being applied more successfully than ever.
And so how do you think these two areas, are they complementary? Can they enhance each other?
Yeah, it's definitely not an absolute. It's a fuzzy boundary between the two, and there is a lot of overlap. But broadly speaking, it is still pretty distinct, right? And so we have that represented in our conference series. The Predictive Analytics World breaks down into a bunch of industry-focused events. So we have PAW, Predictive Analytics World, for business, financial services, Industry 4.0, which includes like manufacturing and supply chain, and healthcare. And in those areas, it's largely more traditional stuff, logistic regression, as we mentioned, decision trees, some more complex ones such as ensemble models. But it doesn't usually get into deep learning except for very particular cases, like if you're doing medical image processing for the healthcare side. And then we started a fifth sister conference called Deep Learning World, right? So I wouldn't call them siloed because there's a heck of a lot of overlap between the communities, both on the vendor side and on the sort of technology consumer and enterprise side. But so they're not strictly siloed, but they are pretty clearly kind of separate communities in a way.
Mm-hmm, mm-hmm. Yeah, and so now when we start talking, starting with Alan Turing, and we keep adding and adding, we are now into deep learning. What do you think it's coming? What is there a pattern which you say, Okay, what I see maybe next 10, 20 years, these are the things which I think will come based on some pattern.
That's a great question. I've never considered myself much of a futurist, although, I do have one major prediction is that futurism is going to go out of style in about 20 years.
Yes.
That's a self-referential joke, but because futurists are sort of like forecasters, like what Nate Silver does, trying to forecast the outcome of the presidential election. He can only just make this one prediction about this one singular event, right? That's a fool's errand, you know. God bless this guy and all the others that do that kind of
Yeah.
poll aggregation, or at forecasting in general, how the economy going to go up or down next quarter. Forecasting is a word that usually alludes to making singular predictions about macroscopic events, right? Whereas predictive analytics, these business applications of machine learning, you're making many, many predictions for each individual. So the Obama campaign 2012 used predictive analytics to target voters individually and decide which ones to contact, with volunteers knocking on the door and making phone calls, right? So Nate Silver won at predicting in 2012 who's going to win the election. The Obama campaign analytics team won at winning the election itself, because you're directly optimizing those mass scale operations.
Okay, perhaps predicting then is the wrong word. Better say what new things, what new concepts you see that they might have some usefulness in coming years.
I think that the thing about deep learning, so in general, when you use predictive analytics, you aren't necessarily predicting accurately. You're predicting better than guessing. So on this side, the business application side, often finding these people that are 3 times more likely to buy, or 3 times more likely to be pregnant, 3 times for that targeting story, right? Whatever it is, you're not necessarily predicting accurately. You're just tipping the balance, predicting better than guessing. Whereas the deep learning applications are places where you kind of need to predict literally accurately. Like, no, this is definitely a stop sign, right?
Yes.
Or this is definitely a cancerous region in a medical image, or these kinds of things. Now, the fact is there are some things that are just not plausible to predict accurately. And unless you have a magic crystal ball, which I would claim does not exist, right? So which customer is going to make a purchase, right? This is human behavior. You're going to predict better than guessing, but you're not going to be predicting like a magic crystal ball. Whereas some things are plausible. We know that doctors can look at a medical image and do a good job at discerning certain diagnoses, or humans can look and say, yeah, there is a stop sign, and get very consistent, high accuracy determinations, and then so can a deep learning model. So I think that deep learning starts to apply where things could plausibly be done with high accuracy. And we know that, for example, because people can do it, but the computer hasn't done it yet. But we need it to be high accurate. So, for example, fake news. So there are places where I think deep learning's potential will grow. A large bottleneck to that is getting the right training data. So I've been mentioning supervised machine learning. Both sides of this is supervised for the most part, meaning that you've got labeled data that you're learning from. That is a bunch of examples, many examples, thousands, tens of thousands, hundreds of thousands. I've even worked on projects with tens of millions, 15 years ago. But for each one of the examples, the right answer already. So there are examples from which to learn. They're learning cases. That overall is called the training data. That's the technical term for it. And when the fact is that kind of data exists in abundance a little bit more on this side than on this side. And this is the side where they've got a lot of new exciting growth, and you can tell where the stop sign or what have you. The difference is that on this side, oftentimes you sort of automatically have that labeled data just as a matter of doing business as normal. It's the residue, the side effect of doing business, because all the data you've collected, all that historical data speaks. You know that in the past, these customers did cancel and these ones didn't. These ones purchased and didn't. These transactions turned out to be fraudulent. Just as a matter of conducting business as usual, we're accumulating all those labeled historical examples. Whereas if you want to have a bunch of many, many, many example images that do or do not represent a certain type of medical disease, do or do not have a stop sign, these are cats versus dogs, whatever you're trying to categorize over here with deep learning with high accuracy, typically those need to literally be labeled by hand by humans. So that's a major bottleneck, right? Now, you might be surprised how quickly you can accumulate with large numbers of people on the Amazon Turk
Yes.
website and these kinds of things, or you can get a bunch of labeled, but it has to be high quality. The stakes are very high. It has to be the right distribution of data, because you've got a potentially self-driving car that needs to see if there's a stop sign and all these kinds of things, or whether there's a pedestrian. The potential is so huge in terms of the core technology, but there's more of a data bottleneck, I say, over on this side.
Right. Yeah. The self-driving cars. Again, we were talking about transparency, and one example I'm always using, that somebody was programming the car and somebody was building all these if statements. And there is eventually a situation where somebody's going to die because of unexpected situation, and the car just won't be able to stop. And I wonder to what extent people will be able to accept that this is how the technology is working, for better or worse, and start using self-driving cars.
Right. It's like a sociological phenomenon around the adoption of that technology. And I kind of anticipate that it's going to create a whole new industry of lawyers, right? I mean, where the responsibility lies across all the different vendors that are creating different models and different algorithms. Right. So if the thing that's driving us, so to speak, is that self-driving cars are ultimately going to cause many fewer deaths than human drivers. But then it's sort of very much analogous to the ethical things. We were talking about ethical things, and I was thinking more on this side, on the business application side. Right now, when we're doing these high stakes operations, right, whether it's flying a plane or driving a vehicle, in both cases, the thing's going to be making decisions, and by certain metrics, the overall decisions as a whole, the net bottom line might be a great improvement over humans, at least by certain measures. But it's never going to be 100%. So then it's going to be a situation where the problem is now we have to be confronted with making decisions about where the errors are going to tend to lie. And we can turn knobs that sort of put errors over here, more over there. Whereas the way in the state of today's world, where these things are generally being done by humans, nobody has to sit down and make an explicit decision. It's an impossible decision, and nobody has to make it yet. So we're going to improve things. If we're going to have to make so-called impossible decisions.
I think that, and to the other point which you made about fake news, the way how I think we can find labeled data, or examples how machine can learn. We have to find more liars and learn, so machine can learn from them. Well,
that's a great point. That's part of the data. When I say you have to have enough data, you need to have both positive and negative examples. So if the thing that you're trying to predict, the so-called positive cases of a certain disease, fake news, cases of fraudulent transactions, if that's a thing that's relatively rare, it's good that it's rare. But the more rare it is, the more difficult it is to have lots of examples from which to learn about it.
Yeah.
And then that certainly applies with operating a vehicle automatically, right? What are all the weird scenarios that might arise on the road, right? Related to environmental conditions and the behavior of other vehicles, et cetera, et cetera. They're all the most interesting and by definition, the ones that are dangerous or anomalous. Because if they're not anomalous, if they're not unusual, they'll be covered by the model.
Yeah. But based on our conversation, it's so exciting to work with data, because from my personal experience, it offers opportunity for not machine learning, but for human learning. We can learn so much. I think that's the exciting part for me.
Well, if the computer learns something, then it's learned it for us. So we've learned it, right?
Yes. Yeah.
But yeah, data is exciting. Almost sounds like an oxymoron, right? Because the world out there, if you walked up to somebody walking down the street here and you say, hey, what do you think of data? They'll probably be like, what? Right? It's because so data seems boring without much thought for this very same reason of why it's so powerful, because in its abstract, it means nothing. But in its particular, it always means something important. That's why it was collected. So the fact that it's so general and can record anything that's happened, any types of history or behaviors, is exactly the same reason people kind of glaze over and think, oh, that weird abstract ones and zeros. But it's a list of things that have happened, right? It's experience from which to learn.
Yes, and we should all be learning, and we should all be reading, and yes, that's what we should be doing. Eric, thank you very much. This was absolutely fabulous conversation. Thanks. I learned a lot. Thank you.
Likewise. Thanks, Vaclav.
It was perfect. So for everybody watching, thank you very much for joining us for this great conversation with Dr. Eric Siegel. All the information, all the links Eric mentioned will be in the subtitles, in the description of the video. And I always urge everybody, go to Coursera and took all the courses which Eric put there. They are worthwhile your time. Thank you very much, Eric.
Yeah, take care. Thank you.